In this portion of our lesson, we are going to work with negative numbers inside the square roots. So here they're asking me to add these two radicals together. The first thing I'm going to do, I see the negative, so I'm going to pull it to the outside, rewriting them as imaginary numbers. So I radical 27 plus I radical 48. So radicals are similar to any variable where you can only add similar variables together. I can only add similar radicals together. The radicand, which is that part inside the radical, has to be the same number in order to add them together. When you're multiplying radicals, you can multiply anything together, but when you add or subtract, the radicand has to be the same. So what can I do to get these two radicands to be the same? I'm going to do the factor tree in order to simplify the radicals. So starting with the 27, I want to bring it down to prime numbers. I'll do 3 times 9, and 9 I can break into 3 times 3. Because it's a square root, I'm looking for pairs of numbers. So this group of 3 gets pulled out. Bring the I straight down. And whatever is left over goes back inside the radical. Do the same thing with the 48. I'll do 6 times 8. The 6 will I write as 3 times 2. The 8 is 2 times 4 and 2 times 2. I always like to go back and just cross off the numbers that I've factored. So again, I'm looking for pairs. I have 1 pair, 2 pairs, and then the 3 is all alone. When you're bringing pairs out, I multiply them together. So this 2 and this 2 will make it 4 I square roots of 3. Now the radicands are the same, and I can add these together. 3 plus 4, my final answer is 7I square roots of 3. What's inside the radical doesn't change, so it would be just like if I were adding 3x plus 4x would give me 7x. When you're adding radicals, you don't change the radicand, it stays as 7I radical 3. Right, let's look at the next problem. We're going to FOIL something with a radical. So negative 2 plus the radical negative 3. Because it's squared, let's write it out twice. When I go to FOIL these, I like to do it leaving the negative inside the radical. I'm going to pull the I out at the very end. So we'll start negative 2 to negative 2. When you multiply a number to a radical, the radicand doesn't change. This becomes negative 2 square roots of negative 3, not negative 6. Going on the inside, that also was negative 2 square roots of negative 3. And then the final one, radical negative 3 times itself. I have 2 of the same terms, so that's the same thing as saying squared. Okay, let's simplify. 4. Now I'm going to bring the I out, representing that negative. So it's minus 2I radical 3, minus 2I radical 3. And here, when I have a square with a square root, They cancel each other out, leaving me with minus 3. Combine your middle terms, and I can add the 4 and the minus 3 together. So I'm left with 1 minus 4i square roots of 3. And there's other ways to do this. There's a shortcut method, but I wanted to show you the FOIL so you get a feel for how you multiply radicals together. Great. Now we're going to move on to quadratic formula. The first thing I want to do is write out what the quadratic formula is. So here's the quadratic formula. We need to assign what a, b, and c are. A is 1. It goes with our first term. B is negative 2. C is positive 2. So they just go in order with the coefficients, A, B, and C. Let's plug them into our equation. X equals opposite B plus or minus the square root B squared. So I'm going to go ahead and just do negative 2 squared and write 4 minus 4 times A times C all over 2A. Let's simplify the radicand. 4 times 2 is 8. This makes it 4 minus 8, which is the square root of negative 4. Square root of negative 4, the negative becomes an I, so I get 2I. Bring it all together. X equals 2 plus or minus 2I all over 2. Now I can reduce. As long as all 3 terms can be reduced by the same amount, I can divide everything by 2, leaving me with 1 plus I as an answer and 1 minus I. Great, so that's using quadratic formula when you've got a complex number. I'll give you one to try. Go ahead and push pause while you do the work and then resume play to check your answer. All right, this is walking through my work. A, B, and C. A is 2, B is 2, and C is 3. I put them into the quadratic formula. I went ahead and simplified the radicand. I got 4 minus 24, which was negative 20. I needed to do the factor tree because you have to reduce that negative 20. Here was my pair of 2's that got pulled out, and the 5 stayed on the inside. So this became 2i radical 5. I brought it all together. Then I reduced all the numbers by 2, leaving me with an answer of negative 1 plus I radical 5 over 2, and negative 1 minus I radical 5 over 2. All right, I have one more for you to try. If they give you a problem where your numbers are on both sides of the equation, you want to set this equal to 0. Anytime we ask you to solve an equation that's in quadratic form, set equal to 0. So I'm going to subtract the 4x and add the 6. 3x squared minus 4x plus 6 equals 0. Now you can set up your A, B, and C and use quadratic formula to solve. Push pause while you do your work and then resume play to check. Here's my A, B, and C. 3, -4, +6. Put them into the quadratic formula. Opposite of B, plus or minus the square root. B squared minus 4AC all over 2A. Simplifying that, I got -56 on the inside. That's the radicand. I had to do the factor tree. 8 times 7, 8 broke into 4 times 2, and the 4, 2 times 2. So when I went to rewrite it, there's my pair that came out. And the numbers that were left over, the 2 and the 7, I re-multiply them when they go back in the radical. So it became 2 radical 14. Bringing it all back together, 4 plus or minus 2i square roots of 14 over 6. Reduce. You only reduce the numbers on the outside. The only time you can do anything with the radical is when you do a factor tree. So these reduced down to 2, 1, and 3. And your final answer, 2 plus or minus I radical 14 all over 3. So I hope you're an expert now with quadratic formula. And thanks for watching.